to show why input signal level makes a huge difference, particularly when you're trying to take measurement of things. If we take a look at the bottom green line here, this is the thermal noise floor of my test setup. As we can see, we have 60, 120, 180, 240, 300. We have a ground loop. And that's because of the power supply. I'm using two different computers. Well, I'm using a computer in the Helix, and they're plugged into different sources, and the power supply on my laptop happens to be noisy. So I get a ground loop. And as we can see, we're at, minus 95 dB. Minus 90 dB is the peak of it. So you would think that as long as you're putting a signal that's louder than minus 90 dB, it wouldn't show up. But if we take a look at the pink graph is a sweep. Now this is done through the Helix, and it's done with a Brit 2204 amplifier. I just took amp and cab, factory settings, dropped it in the path, turned it on, and this is what I got. Now if you'll notice, this test signal, this input signal, was minus 75 dB. And if you'll notice, you still see the noise floor. You still see the ground loop. The reason we see that is because the amplifier is also amplifying this. The input signal is cumulative along with the noise floor. As we see it at the top end here, the amplifier is, again, the curve here is actually because of the speaker cab. It's like a filter, and it cuts off the high end. And once it cuts off the high end to a point, it truncates. And this here would be our noise floor. Now our amplifier is adding, what, 10, 20, 30 dB to our test signal. So it's adding it to the ground floor, and it's also adding to the noise floor. It's also adding it to our test signal. So we still see these spikes. Again, I went up 15 dB at a time. So this is minus 70 dB. This would be minus 60 dB. Still showing up, but it's starting to diminish. Once I get to minus 50 dB, it's almost gone. And once I get, let's see, so it was 75 minus 60, minus 45 dB would have been this one. This would be minus 30. And when I got to minus 30 dB, it's gone completely. And then this would be minus 15 dB. And as we see, as I put a minus 15 dB signal to the amplifier, it's starting to compress up here. And you're starting to see some deviation from the line. In other words, the amp can no longer get any louder. But the reason I point this out is because anything that's in your thermal noise floor will be combined with any input signal you get, and the amplifier that you put in the signal path will amplify it. So if you are running an extremely quiet signal when you try and run a test, you're likely to get anomalies in your test data. You're much better off running a louder signal so your equipment can measure it more easily, and you'll get better data.